my name is Giacomo Zanetti. I'm a PhD student at the Technical University of Denmark, DTU, under DTU Electro within the Optical Sensor Technology group, and I work on the Night LiDAR project. My responsibility within the project is to develop fast spectroscopic techniques to remotely measure CO2. So why do we need to measure gases remotely and in a fast manner? Well, the advantage of measuring something remotely is that you highly reduce the number of sensors you need to cover the same area. If you use many point sensors over an area, the bigger the area is, for example, an industrial plant, the higher the number of sensors you need. Whereas with remote sensing, you might need just a few that can cover a bigger area. Also, you have the advantage that if you have point sensors that need to be used by humans and the gases you're dealing with are dangerous, using a remote sensor, you don't expose the workers to the gases. The second thing is to make it fast. And the reason for that is that in the case of a leak, for example, where you need to be tempestive with the intervention, you need to have real-time information. And to do that, you need a fast system. So how does spectroscopy work? We are using a laser and a detector. And what happens is that the laser emits light at a very specific wavelength, which means a very specific color. We call this monochromatic source of light. So the lasers you might buy at the store are red, for example, or green, and they are a very specific type of red or green. They're not the highest quality lasers, of course, but they still have somewhat of a monochromatic property. Your eyes will never be able to differentiate the red of a laser that you buy at the store and the same red that the laser is emitting the day after. But the battery of the laser might have depleted a tiny bit because you were using it to play around or play with your cat or something like that. So actually, the color has changed ever so slightly. Although you might not notice, the interaction of the light with molecules in the air might be slightly different. And that's what we are trying to exploit for spectroscopy. Spectroscopy is just a term we use when we talk about measuring concentration of gases, looking at the interaction that light has with the gas molecules as a function of the color, so as a function of the wavelength. The challenge here is that to extract a precise value of concentration from this type of measurements, we need to wait for a few seconds. Although it might not sound like much, if you think that you need to make many measurements to scan over a huge area, for example an industrial plant, then this translates into possibly waiting minutes before you can actually detect a leak, and it might be too late. So my task here is to find a spectroscopic techniques that relies on the same principles, but is much faster. Having a fast spectroscopic techniques fits perfectly within the Night LiDAR project because it can be combined with the fast steering capabilities of the optical phased array, or OPA for short, which is the component that is being developed by most of my colleagues within the project. In fact, using the properties of the optical phased array, the laser beam can be steered in different positions without having any mechanical components. And of course, if this laser is being moved and we want to measure concentrations as well, we need to have a technique that is able to keep up with the properties of the optical phased array. So we are now in the lab to take a look at how the experimental setup actually looks like. We have the laser, which is at the specific wavelength to target CO2, one of the absorptions of CO2. And then the laser comes through an optical fiber all the way here. Then the laser goes through some optical components, and we have a gas cell which contains the CO2. The signal bounces off a mirror and goes back here and to the detectors here. Now, this signal is a photonic signal in the sense that the information is carried in the light that is coming to the detectors and is now transformed into an electrical signal by the detectors. Then this electrical signal is carried by the wires, and then we have all of the electrical components to take care of the signal processing. To summarize, I develop algorithms for fast CO2 quantification, and I put together the efforts of my colleagues at Night LiDAR to produce a system able to remotely map CO2 emissions.